section 4.5, the principle of superposition and undetermined coefficients. We're given that y1 solve this differential equation. Y1 in blue solve the equation I just shaded in blue. And then y2 solve the equation that I'm shading in yellow. Notice that both differential equations, the left part of the equation is exactly the same. So we're given the problem that y1 is a solution of y double prime minus 3y prime minus 3y equals to 3 e to 2x. And y2 is a solution of y double prime minus, this should be a 2, minus 2 y prime minus 3y equals to negative 5 cosine of x. So again, notice that the left portion of the equation is exactly the same. So we have to find the particular solution to the equations in parts A and part B. So let's do part A. So we have part A. We have to find a particular solution to second derivative of y minus 2 first derivative of y minus 3y equals 2, 3 e to 2x minus 5 cosine of x. Now, notice that y1 is, as given in the problem, y1 is negative e to 2x, and then y2 is cosine of x plus 1/2 sine of x. Okay, so these two are solution, respective particular solutions as given in the problem of the two differential equations. So we have to find solution to the equation in part A. Notice that this term is the same as this, and then the one in pink is the same as the one in pink in the equation we have to solve. So we can apply the principle of superposition and find a linear combination that allows to solve the equation in part A. As you can see, the green parts are the same and the pink parts are the same. So the particular solution is going to be, in this case, simply y1 plus y2. Okay, so the solution is going to consist of y1 is negative e to 2x plus cosine of x plus 1/2 of sine of x. Okay, this is y2 and this is y1. Okay, now we have a second example. We have example B. In example B, we have to find the particular solution y2. What? Okay, the left part of the equation is exactly the same. It's the same thing. Is y double prime minus 2y prime minus 3y. But now the right, remember the right is, okay, this is f of x, right? This is f of x. It's a non-homogeneous equation. So we have negative 9 e to 2x, negative 9 e to 2x, plus 10 cosine of x. So this is the equation we need to solve by finding a particular solution. Okay, so what is this equal to? Well, notice that y1 solve this equation and shade it in green. Okay, and then y2 solve the equation and shade it in pink, we can say. Now, in the given equation, here we have a 3 and here we have a negative 5. But in the equation we have to solve, in the new one, look that we have a negative 9. Okay, this term kind of look like the one we have on the right. Let's say that this is f1 of x and this is f2 of x. Okay, so f1 is similar to the first term on the right of the second equation we have to solve, and if you notice, f2 is similar to the second term on the right for the second problem. So the question is, how can we obtain a negative 9 from a 3? And how can we obtain a 10 from a negative 5? Well, simply, then, in this particular context, the particular solution is going to be, well, negative 3 times y1, because negative 3 times 3 is going to produce a negative 9, right? Plus one number multiplied by negative 5 produces a 10. That number is obviously a negative 2. Negative 2 y2. Okay, so we have found a linear combination using the principle of superposition. So what's going to be the solution? Well, what is y1? y1 given in the problem, given in the order of the problem, is negative e to 2x. So it's going to be negative 3 e to 2x, right? Minus 2y2. y2 is also given in the problem. y2 is what? y2 is cosine of x plus 1/2 sine of x. So we have to multiply that by negative 2. So what are we going to get? We're going to get negative 2 cosine of x minus sine of x, right? And then this is the particular solution we have arrived at using the linear combination from applying the principle of superposition.